Hi, I'm Austin Chu from 971. I'm essentially our lead technical mentor. So when the challenge comes out, what we end up doing is we try not to have crazy designs. We try and just be a little more mainstream. So like this year we looked at it and we said we want to be able to shoot in the high goal and be able to pick up very quickly. So that was essentially our entire brainstorm. And we weren't really sure how the game was going to play out, and I don't think anybody was. So our goal was to design a robot that could do whatever we wanted it to do. So we tried not to box ourselves into a corner. And so we focused on the intake. We looked at 1114's 2008 robot. We really liked it. We wanted to do it with a 971 flare. So we looked at the intake. We figured out how to get the rollers to suck it in quickly. We figured out that if we rotated the tuss, this was all in prototyping, that we could get it to center faster.
And how many prototypes do you guys think you had?
There was like one prototype that iterated through 3 or 4, we modified it 3 or 4 times, kept improving it, and that ended up being our claw. And then we tried a catapult, and that didn't work so well. We never tried the roller shooter, the flywheel shooter, and we tried a linear puncher, which is what we thought we wanted to make. And we were able to get that to be reliable enough with our prototype, so we used 80-20 and pulled it back by hand, and we did that. We actually put our claw prototype on an old robot frame, kind of got it to work. We were able to pick up balls that way, and we kind of vetted everything out that we thought we'd want to, and then we went to the design. So we tend to be more organic in our design. So we start out with a big picture. We want to shoot balls or something, and then we start looking at the pieces and figuring out how we're going to fit them into base. So we start with a sketch, generally a single sketch from the side of the robot. And we look at the geometry. So as the claw moves through its range of motion. Oh, another one is we want to be able to go over the back. So as the claw moves through the range of motion, how do we stay in base? How do we get the ball to the positions we want to get it to? How do we do all that? Another really important one for us is we wanted to be able to tuck in. So as you're looking around the field to go pick up the ball, you want to be able to get your robot safe so you're not going to get penalties and not going to get broken. So that's actually what drove our split claw design. So we knew we could do it, and that let us get the robot tucked in better. And after that, it was just a lot of hard work and iterative design to get the CAD in shape, and we shipped it out at the end of about week 2. So then we had 3-week turn on our parts from our sponsors, assembled it, and there it is.
Cool. And when did you guys say you finished, say, the main part of your robot and were able to start getting a program?
Programmed?
Or like you finished like the construction of the robot to the point where the programmers could start?
About 12 hours before ship.
Okay.
So what we do, our software is very unique. We write everything in simulation first. So we have simulations for all our drivetrain, all our claws, our shooter. So we're able to write all the code and make sure it works before it ever gets the hardware, which reduces the number of things we break. So we started like a week or 2 before ship, as soon as I was able to get free. And we started writing code. And it wasn't until ship day that we were actually to the point where we were willing to start running the code on a robot.
Okay.
So we're unique in that way. Most people start on a robot because it's easier.
Okay, so as you can see, our wheels are, they can be taken out. They have a free axle, and the pulleys and the gears are all attached to the wheel. So this is our center wheel, so it's larger than the outer wheels, so we have more traction. And the way we replace our pulleys, our belt, we just detension the wheel so we can pull the axle out, then we drop the wheel out. We do that both with the center wheel and the outer wheel, and then that allows us to just take the belt straight off and put the belt straight back on, and that's how we tension our belts as well as tension the wheels. Cool. So in place and take the bolts out.
And how do you guys attach the tread on your wheels?
So if you look at our custom wheels, we've designed them. They sell these on AndyMark, like a similar design, but they aren't as nicely done. This is what they look like without the tread. So inside we have a zip tie, and what we do is we take our tread and we fold it over and we push it inside and then put the zip ties around it so that we can then tighten the zip ties so that it's quicker and easier to remove than rivets. And also rivets, sometimes it's a pain because you can damage the wheels. So this way it's, the wheel's completely reusable, really quickly to change, and also because it's one complete unit, if need be, we can just switch it out really quickly for a new wheel in the middle of the match.
Now, is this the same as your outer wheels?
It's almost identical to our outer wheels,
except it has the drive gear on the end.
It just has the drive gear which goes into the front of it.
And it's it's wider, obviously.
Yeah, it's almost triple the size, triple the width.
They're also slightly larger.
Yeah. And how do you guys do your belt tensioning?
So we have a that's actually an interesting story this year, because normally we got new belts this year. So previously we kind of just felt it, and if it felt kind of tight enough, we went with it. This year we went with the belts that I think it was less elastic. So when we push at the same point, it would reflex the same place. But really what was happening is it wasn't right. Even though it felt right, it was over tension. So we kept breaking our wheels. So we ended up using a frequency to check that our
belts are 45 hertz now. So that way we
45 hertz. And how do you guys measure that?
Well, we use like a tone generator. We just listen.
Yeah, like so you get a tone generator.
It's not absolutely exact, but it's pretty approximate. It's good enough that we don't break belts anymore.
45 hertz.
Yeah. Well, it depends on the belt. Depending on the belt, like you can look up on the manufacturer what the force is meant to be on it, and I forget the physics how you work out the exact frequency.
Cool. So, what is the mechanism itself that tensions the belt? Is it you tension the axle, or is there something that comes down on the belt?
You actually pull you have like a block where the axle is attached, and it has screws in it, and you actually pull the whole block back so that moves the entire axle with it.
So you tension it from both sides?
Yeah, we tension it from both sides.
Okay.
That's pretty
well, cool. Thank you guys so much.
I like to think of sheet metal as paper. It's a good analogy for me. Every time you bend paper, it gets stronger. So you can you want to put bends in sheet metal to make things stronger. We work really hard to not break the bends. So if you have a long element going down, like your frame rail or something, we try not to put things that intersect the bends.
What do you feel about the shape of the drivetrain? Like rectangle versus octagon?
Yeah, so the octagon has been really awesome for us this year, but it blew up the drivetrain complexity. So our drivetrain went from 4 parts to closer to like 10 unique parts, and those were a lot harder parts to design. So I would be cautious recommending someone new go to an octagon. Just at least draw the square first. It's a lot easier. Right angles are easy.
Yeah. Okay.
And make sure to think through your load paths. How you're going to get your load into your bends, into the strong parts of your frame, or whatever structure you're building.
How do you feel about splitting the frame in the front, or say maybe the back for an intake? Or
I'm a little cautious. It's been really nice having bumpers protecting the frame. Everything seems to last longer. Like this year, we just pulled it in over the bumpers. It wasn't a big deal. I would be tempted to look at last year, seeing if we could pull over the bumpers a little better, just because that part of our robot really got beat up.
Yeah. And how do you feel about making the bumpers, like incorporating the bumper frame into the design, rather than putting like all of the strength into the frame itself?
We've had a lot of luck with the one-piece bumpers. We make sure they fit really tight, because that couples your loads in better. If there's room for things to rattle, there's room for things to accelerate and all that, and that's not good. We've been doing just the one-piece wraparound bumper, so it fits in snug, and we've been using essentially latches, over-center latches, like for luggage, and just lay the bumper over the top and latch it in. So it's like a couple 1 or 2 minute operation to swap the bumpers, which can be really nice. And you can get, with the wraparound bumpers, you can get the fabric really nice and tight. So we work really hard to cinch everything down and get good tight bumpers so everything works well.
How do you feel about the integration of gearboxes into the frame or sheet metal parts?
It makes it harder to repair things. So we do it in a couple spots where you really need things small or tight. Like we integrated our TUS gearboxes into that cross rail on our intake. But for like our drivetrain and for our intakes, the top rollers, we left the gearboxes separate.
Yeah.
So we just left them flat plates, and you can also assemble it outside of the robot and maintain it outside of the robot and all that if you need. It makes it a lot easier.
How do you feel about the thickness of drivetrains? A lot of teams use 1/8-inch thick sheet on all their frame pieces.
We use almost exclusively 090. I would use 1/8-inch where we have impacts, so something's exposed, but with the new bumper rules and everything, that's not really a big deal. So we've been running 090 on our drive base for a couple of years now, and it holds up great. This year, actually, the first battle damage on our drivetrain was here, when someone propped us up and then rammed us. So that's 3 competitions, and all sorts of practice. So it holds up just fine. I'm torn. I'm half tempted to try 060 some here on the drive base, but I just can't. You can't bring myself to do that just because it's too critical. One thing we've chosen to do is we run tube stock for the long distances, because it's really hard to beat the weight and strength of 6061 T6 tube, which is closed and everything. You'll spend twice the weight and it'll be weaker if you do it all in sheet. So you'll see that on our robot. All the long distances are done in tube, all the short distances are done in sheet, all the intricate bracketry and intricate parts.
Yeah, because I've seen teams do that, like 148, I noticed, instead of using tube, they actually bent sheet metal into a tube shape for most of their superstructure.
They have a great sheet shop, and they probably don't have as much access to tube. It's harder for them, and we've just found that it works better when you do it with tube. So we make sure to design access in for everything. So explain what there's two wall tensioners, one on each side of the wheel, that are captured with a bushing in it, and it's a dead axle. It's actually our wheel. So it's a dead axle. So there's a tensioner. There's a tensioner that pulls each side with 2 bolts, and then there's a hole in the frame. So when you detension it, the axle lines up with the hole, and you shove it out, and you're done.
Wow, very nice.
One in the travel set. I'd like that. Someone grab it. I bet it's in that white. Has put a lot of wire plugs in.
Iterative design. It's about our 3rd year doing this style frame.
Slide the crate out so you can see it.
Every year it gets that much better.
Hey, I noticed that there are 2 sets of each kinds of Allen wrenches, so somehow it made it back.
Wasn't me.
Turn it over.
Yes. Plus the corner.
Is it lined up on your side?
It's lined up.
Does it want to go?
We gotta punch the wheel.
Get it out yet?
Shove it in further.
Yeah.
Push it in.
Alright, now the wheel's out. Now we get
Well,
Yeah, that was
not very. Hey, just quick. Daniel, you didn't even have to pull it out and risk messing the belts up. You could have just left it down there.
Yeah.
It's all risk. I'm Austin Shue from Team 971.
Austin Shue from Team 971. Thank you so much.
Robot's almost exclusively 090. There's a bit of 060 in there somewhere. I don't remember. I'd have to go find it. We have like 2 1/8-inch plates. That's it.
Cool.
We've been sizing down over the years. And in the end, it depends on the application. It's whatever we think will be strong enough for that.